Welcome to CS1203 Database Systems 1. This is the Unit 8 lecture, Part 1. In Unit 8, we kind of wrap up all the concepts that we've had in the course, and we kind of put a bow on top of it by looking at how we start to tie all that we've learned about databases into the rest of the programming paradigm. So that kind of means, once I have the database and once I have the structure and once I know how to leverage SQL to manipulate the data in the database, what I generally want to be able to do is start to develop programs that take advantage of the data that's in the database. So one of the things we're going to do in Unit 8 is we're going to do kind of a high-level view and try to understand some of the concepts in this really huge area of database programming. So what we're not expecting everyone to learn to do in Unit 8 is to really kind of get a in-depth understanding of what database programming is all about, because quite frankly that would take at least one and perhaps several additional courses to really get a sense of what's going on there, because there's a lot of material that we have to cover. Now, what we would like to do today, however, is just to introduce you to some of the basic concepts, and you can take that information perhaps and then do some additional research on your own and really kind of be able to do some simple database programming using what you already know about SQL and databases and designing data models, and then perhaps adding to it some of these concepts of database programs. So there's three key topics we're going to talk about today. One of them is embedded SQL. Another one is cursors, and then the ODBC and JDBC interfaces. We're going to talk about each of those, a little bit about how they work, etc. But before we get into that, what we want to do is just take a quick moment to define a few terms and give you guys a little bit of a view of how this typically works. Most of the time when you see database programming being done, it's implemented in one of two different kinds of models. And one of them we're going to refer to as is the two-tier model. And the two-tier model, essentially what happens there is that I have some kind of a program, and that program uses some form of an interface, and that interface is going to be providing us with an ability to communicate with a database. In some cases, I might be using an interface such as ODBC, or another one that we have called JDBC. ODBC stands for Open Database Connector. JDBC stands for Java Database Connector, although there are many others. For example, there are a variety of different proprietary API technologies that allow us to embed database functionality within a programming language. A very popular one, and one that I've used extensively over the years, is all of the embedded APIs that are offered by Oracle. There was a product that Oracle still supports called Pro-C and Pro-COBOL and a whole bunch of different languages. And essentially, those represented APIs that implemented embedded SQL. But in all cases, this interface component acts as a client to the database, and it establishes a connection, as you can see represented by this line, between the client or the program that's attempting to do some form of interaction manipulation of the data within the database and the actual database itself. And typically the way that this works is that this connection is established by the client process using this API technology, whether it be a proprietary API like the Oracle APIs in SQLnet, or ODBC or JDBC, or another one of the another one of the database connectors that are available out in the marketplace. This client process will tend to establish a connection to what they call a listener process. In most database products that can be implemented in a server form, and obviously what we're doing with Open Office database, it's actually very similar to this. It's just that we don't see how this happens, and the listening processes and that ability to create the connections all embedded within the tool. But it's happening. So essentially what happens is that we form a connection to the listener. The listener is just a process that sits out there and listens and waits for a connection request to come in, and then it can establish a connection back into the database and process those requests. That is a two-tier model, because the two tiers are the client tier and the database tier. There's also a three-tier model, and we see a lot of this implemented in what they call SOA, or service-oriented architecture, or in our web-based architectures. And essentially what happens in this particular case is that the client doesn't directly interface with the database. It actually interfaces through some form of an application tier. So you have an application program. That application program is actually creating or using the database interface technology, the ODBC or JDBC or one of the proprietary ones, and it creates the connection into the database. You might hear a term called connection pools, and one of the things that some of these technologies do is they kind of go out and they might establish a whole bunch of these connections, and then whenever one's free, then the application can use it. So it kind of saves time in establishing the connection, because typically what happens in this connection process is that you go through an authentication. You have to give it a username, a password, etc. So in this model, we refer to this as the three-tier model, and you can kind of get the sense that there's three tiers: the server tier, an application tier, and the client tier. And this is very, very popular. You see this a lot in web applications, SOA applications, enterprise applications, etc. So these are a couple of terms of architectures, how this is implemented. It's important because all of what we're going to be talking about in terms of database programming is happening right here. So we're really kind of looking at programming this interface and using this interface to send our SQL statements down to the database and to try to get the responses back from it. So move on, and we're going to look at the first of the different interfaces we want to talk about. And the first one is ODBC, and ODBC stands for Open Database Connector, and this is kind of the ODBC architecture, if you would. But essentially what you have is an application. That application will be able to interface with a series of APIs. Now, when I say API, it means Application Programming Interface. And when you go into any particular programming language, you're going to find that those programming languages have libraries of function calls or methods that you can call that do specific functions within that language. And essentially what ODBC is, it is an API, and it provides a series of function calls, and those function calls allow us to establish a connection through the driver infrastructure to the database and execute our SQL operations against the database. Now we're going to talk about a little bit about this whole concept of API, because as we start looking at the differences between embedded SQL and these interfaces, the ODBC, JDBC, or other programmatic interfaces, what we find out is they're essentially the same thing. ODBC, essentially all that it is a very common and consistent interface that somebody has taken the time to implement on a whole variety of different programming languages. But what happens here is that you as the programmer have to know the particular function call to use to do something such as establishing a connection with the database, or executing a SQL query, or issuing a update type of a transaction, or creating, opening, managing a cursor. So you have to understand enough about the various function calls within ODBC in order to be able to use and program access to the database. In embedded SQL, there's still the function call, but it's implemented very differently, because with embedded SQL, the programmer will sit down and write their SQL commands and write them basically right into the source code of whatever programming language they're using. So for example, if they are using C, they might write some C code, and then they'll have some SQL code, and then they'll have some C code. So they're embedding their SQL code right within their C code, or their Python code, or their Java code, or their C++ code, whatever it is that they are in fact writing. And what happens is that that code then goes through what they call a pre-compiling process. So you run a program against it, and what that program does is it looks for all of those instances of embedded SQL, and it strips them out of there, and it replaces them with a series of API calls that actually implement it. So in both cases, it's accessing the database and executing those database functions through an API, through a function or a method that's being called directly from the language. But how those APIs are called is different, because in one case, ODBC, and as we'll see, JDBC, I have to know what all of those function calls are and just use them. And in the case of embedded SQL, I write the SQL, and there's a program that's smart enough to know what the proper API call is to put into the software code. Now, what we're going to do is just take a really quick look at ODBC that's been implemented in Python. I know that a lot of you have actually had some experience working with Python because we've used Python in our Programming Fundamentals course. But basically what you can see in this code, and I'll just highlight a few things. Here we're importing the ODBC module. So in Python, all of these libraries we refer to as modules. In this particular case, I am using a particular API call, and this one establishes a connection with a database. In fact, this particular database is called MS SQL, or it's a MySQL database, or a Microsoft SQL Server database, and we're just identifying the fact that we're coming from Python. So this is actually a data set name that gets set up out there. You can see this call here is creating a cursor. This one here is getting a list of all the tables, and this one's actually fetching all of the rows from the cursor. So again, you can see where essentially what's going on here is every one of these is a API call, and we just need to know what those calls are to do the different kinds of functions from a database perspective. This one happens to be an example in Python. So let's look briefly at JDBC. And if you kind of look at the architecture of JDBC, one of the things you're going to notice is that JDBC is exactly the same architecturally as ODBC. The only thing that's different between JDBC and ODBC is that JDBC has been developed specifically for the Java language. So it actually stands for Java Database Connector. Now, with ODBC, the way that I use those function calls, even though they're basically named the same, and the basic functionality that ODBC provides is always the same, the specifics of how it gets implemented in a particular programming language may be different. So the way that I call a method in Java is different than the way that I might access a function within Python, which might be very different from the way I would access a instance of a class in C++. And of course, it would be different still from what I might have to implement from a procedure, subroutine, or function call within C. JDBC is a little different in the fact that since the only language it is dealing with is Java, and since Java is implemented as a common language that runs in a virtual machine, the implementation of JDBC is always the same, regardless of what computer it actually is running on. So we can look at just a real quick example of a JDBC implementation. And you'll see that we're doing this, in this particular case, using the Java language. Up here, we're actually importing all of the JDBC libraries that we're going to be using. And you can see down here that we've got a class that we're defining. And within that, we're setting up our connection string. We're connecting to the database. In a lot of ways, it looks very similar, although the names of the functions are different. The kinds of things that you see here are very similar to what we saw in the Python example. Again, the big difference with JDBC is that it's exactly the same regardless of what computer we're going to be developing Java for. Now, we want to look a little bit at how this is different from embedded SQL. And we're going to look at two kinds of embedded SQL. One we're going to call static, and the other one is dynamic. Now, the big difference between static and dynamic is that in a static embedded SQL, every single bit of the SQL statement is embedded. So in other words, I need to know exactly what the SQL statement that I need to execute is when I'm writing the source code of my program. And it never changes because it's then compiled that way. And the way that you see that we typically will introduce embedded SQL into a program is you kind of prepend each command with this exec SQL. So when the preprocessor is going through and it's reading through the source code, every time it sees one of these exec SQLs, it will replace this statement with a series of variable definitions and or API function calls that would be appropriate for implementing the SQL. And so essentially what we're seeing here, and a great example here, is how I would implement a select statement. So I'm just going to kind of put a box around this. This, as you will probably recognize, is just a select statement, very similar to what we were doing in Unit 7. We're selecting a customer ID, a salesperson, a status. From the orders table, I have a where clause, which is where the ordered ID is equal to. And by the way, when I have a colon in front of something, that colon indicates that this is not a column, but in fact, it is a variable that is known and recognized by the operating system. And in fact, you'll find that we have that declared up here. So that gives me an ability to pass information into the SQL statement so that I can actually give it a value at the point in time where this is executed, and the value in this case would be the order ID. Now, one other thing that's a little bit unique is you're going to see this into down here. And essentially what that is doing is it's saying I'm selecting the customer ID, the salesperson, the status. From the orders table, I've set up my where clause, and all this statement does is it tells the preprocessor, and it tells Oracle, or I should say SQL, where I'm going to store the results of that query. So it's essentially saying when I retrieve the customer ID, I'm going to store it into the operating system variable, the variable that's known to this language, called customer ID. And when I retrieve the salesperson, it's going to store it into a variable called salesperson. And when I retrieve the status, it's going to store it into a variable called status. And you can see that all of those variables are actually defined up here. And so this is a way that I'm able to pass information from the SQL language back to the database or the programming language that I'm using. And by the way, in this case, this is actually the C programming language. And vice versa. So I can pass data in. The example here is the order ID, where I've passed something into the where clause so that I can provide a condition on the SQL statement that I'm executing. And I'm passing the data out using the into clauses into a series of variables that I would have here. We're going to talk a little bit later about the concept of a cursor. And a cursor is really going to be highly related to this, because essentially all we're doing with a cursor is we're setting up a variable to return the results into that happens to be an array. Array meaning that it can have multiple values in there. So if I return, or retrieve data that is more than one row, so let's say I were to retrieve in my query 30 rows, I would then size the array represented by these variables to have 30 positions in it. So let's kind of move on and look at the differences with dynamic embedded SQL. So in the static case, the entire select statement that I wanted to execute was actually put into code. It was written right into the code of the program. In this case, what you see, it's very different. Essentially what I'm doing is I'm going out and I'm defining a large string variable. In this particular case, it happens to be 64 bytes long. And what I am, and I'm doing, I believe, another one here. But essentially what we are doing is we're defining a large string, and we're actually writing the SQL statement into the string. And why this is important is because since it's just a variable, I can actually change that SQL statement. So I don't necessarily need to know exactly what the SQL statement is when I'm writing the code, because I can change it programmatically when I'm actually executing the program. So for example, I might want to change some of the data values. I might want to even change the query based upon maybe options that are selected in the program, or maybe I would like to sort the data differently. Perhaps the program that I'm trying to write is a reporting program where I'm going to report information, and so I have the option of perhaps changing the order by clause simply because I can change the data that's in this variable. So I'm not writing this SQL statement out there. I'm actually putting that SQL statement, embedding it in a variable, and then I use this kind of a mechanism that allows me to execute the variable. So the variable contains the SQL statement, and I'm passing that to Oracle saying, go execute this particular SQL statement, and that statement is in this variable. And you can see, again, in this case here, we have a SQL statement that I have identified the entire statement. In this one, it's all stuck in the variable. And again, this is the big difference between dynamic SQL and static. Static SQL, I have to write the entire statement out in advance, and it's compiled as part of the program. Dynamic, I put it into a variable, and because it's in a variable, I can change it as I need. Now, the last thing I wanted to talk about in this lecture is this concept of a cursor. So we talked a little bit about the fact that with embedded SQL or with the APIs, part of what we're doing is I have to have a mechanism that allows me to pass data from the SQL language to the programming language that I'm using and back again. So I might want to pass data into the SQL language. Maybe that data is the SQL statement itself. Maybe that data is the values in the where clause that changed based upon the execution of the program. And I also want to get information back from SQL. Most of that will be, for example, the status of what occurred when I executed a update statement, for example. Or perhaps I'm executing a select statement and I want to get and retrieve the values back. Now, as you can probably well imagine that, SQL works as a functional language. It deals at the level of the set. On the other hand, most of our programming languages are procedural programming languages such as Python or Java or C or C++. All are going to deal at the level of a variable or a specific record of information. They're not real good at managing information that's a set. So one of the things I have to be able to do is if I actually execute a SQL statement that returns multiple rows as a result, I have to have a way of getting each one and processing each one individually. And that's where the cursor comes into play. And think of this model that we have here. Let's imagine I have a select star from book, which is a query that we have executed in previous units. And if you recall, it returns quite a few rows. It's not going to return one row. It'll return as many rows as are in the book table. And if I were to send that statement to the SQL database, what's going to happen is that I'm going to have a whole set or a list of rows that are going to be returned. The problem is again, if I'm trying to get data, bring it back into a variable, now I have too much. I can only deal with one at a time, and that becomes a bit of a problem. So what a cursor does for us is it allows us to go send that statement to the database. It allows us to define a large area of memory where I can have multiple values such that when the results come back from SQL, it will populate this array. And once that array has been populated, then I have this concept of a fetch routine or a fetch call. And all that fetch does is it says, go get just one of those rows and return it. I'm going to work on it. I'm going to do the processing of that information, whatever I need to do. And when I'm completed, I will fetch the next row. And so on and so forth until I've completed going through all of the information. So I'm just going to give you a real quick example of what that looks like from the perspective of embedded SQL. So we're looking again at an example that is C, and we're using embedded SQL. And essentially you can see that I go up here and I'm defining a cursor. And it's important about this idea of defining the cursor, because what happens when I'm defining it, or in this case the word that we're using is declaring it, is it's telling the system to go allocate some memory or some space for those results. I then go open the cursor using a particular SQL statement. This would be a dynamic SQL statement. And then I can go, and you can see these statements down here, which is I'm fetching. So essentially what the fetch does, it says fetch from this cursor that I'm calling driver underscore cursor into this particular variable. And I can do this over and over again until all of the rows have been fetched, all of the processing is complete, at which point in time I can go out and close that cursor. So hopefully this has helped to give you kind of a high-level view of some of the concepts around database programming that we're going to be looking at. Again, just to kind of recap, embedded SQL, we have two types, static and dynamic. Static means I'm going to write the entire SQL statement as code in my program, and it gets processed and it doesn't ever change. Dynamic means I'm using variables to write my SQL. So I write my SQL statements, I put it into a variable, and because it's in the variable, I can change it at the runtime of the program. In both cases, what I write into the program code gets translated into a series of API calls. So what actually is executing in there is a series of function calls or a series of methods that are being called and executed. In the case of ODBC and JDBC, I've eliminated this step of trying to write my SQL right into the code of my program, and instead I've opted to use the API calls directly. And that's all that's going on with ODBC and JDBC, is it provides a set of relatively standard and easy to use function calls that I can just simply call directly to do the different kinds of manipulations that I need to do with the database. And then finally, the concept of a cursor. It's just a mechanism that allows me to deal with multiple results coming back from the database. So where typically in a procedural language, I can return one result, I can deal with one piece of information at a time. This simply defines and allows me to define a large array such that when I have multiple results coming back from a query, they're stored in the array and allow me to fetch them one at a time so that I can effectively deal with them with my procedural programming language.